Hello, my name is Lars Bjorndal, and I'm presenting my research on the drying of the spherical aggregates of the filamentous algae Oedogonium. Algae cultivation continues to gain popularity as the world is turning towards more sustainable technology. However, in most cases, harvesting and drying costs remain too high for algae farming to be commercially viable. Filamentous algae, like Oedogonium, provides a potential solution to this as they grow in long one-cell thick strains, aka filaments, which are much easier to harvest than typical microalgae. Further, Oedogonium has been seen to self-entangle and create the spherically shaped aggregates, which are even easier to harvest. However, in a previous study I found that aggregates generally dry slower than unaggregated Oedogonium. Therefore, this project investigates if a fracturing treatment, essentially consisting of putting the algae through a blender and reducing them to a slurry, can reduce the total drying time of aggregates. To perform this experiment, aggregates were sorted into 3 groups based on their size, as seen on the bottom row of this image, and half of the aggregates of each group were processed and reduced to a slurry, as seen on the top row of this image, creating a total of 6 groups. These 3 samples from each group were then dewatered before being dried in an oven at 50 degrees Celsius or about 120 degrees Fahrenheit, with their weight being measured every 15th minute. From these results, you can see that the moisture ratio of blended aggregates, shown in orange, fell much faster than unblended samples, shown in blue, for the small and large aggregates. And although the difference is smaller for medium-sized aggregates, and the intact aggregates initially appeared to dry faster, the blended samples still reached a complete dryness 15 minutes before the unblended samples. Moving on, this table summarizes the total drying time of each algae group and how much time each group spent in each phase of drying. As you can see, the fractured groups, which are shaded in gray, had a shorter falling rate period than their corresponding intact groups, which suggests that fracturing allows algae to dissipate more of its internally bound moisture before its drying rate starts to decrease. These results confirm the fact that fracturing aggregates is an effective way of reducing their total drying time. However, the small effect this had on medium-sized aggregates should be further researched. Before I finish up, I would like to thank Dr. Ann-C. Wilkie, who has assisted me throughout my research and has been an essential resource for the completion of this project. Thank you very much.